and then scroll down to the value changed event and uncomment uncomment these guys over here. Let's see, uncomment not this particular okay, so the value change event of that DTP early payoff, which is this guy here, date time picker, okay, gets triggered every time a value, which is a date, in this case, is changed. So every time we select a different date from this date time picker here, okay, this event will get triggered. When that happens, what we need to do is to quickly instantiate the new loan or credit type. Now the question might be, what happened to the one we had before? Well, when you hit the end sub of the click event, what happens is the default destructor, as opposed to constructor, will actually destroy that credit object, although the memory will still be reserved because it's a class level or program level or global object. Okay, so destructors as opposed to constructors in most programming languages are implicitly called when you reach the end of a particular sub or end of the program, in this case, right, to properly clean up resources. And some, and programmers will explicitly define them and do certain things. But for us, this is we're sort of not really dealing with that. And all you have to remember is when you hit the end sub, that credit object, its values get sort of wiped out, just like any local variable you would declare in a particular event procedure, such as the click, right? So we recreate a new one. Okay, it's again using a default constructor. We could have used the different one, and then we quickly read the values in, just like we did before. So I'm not going to repeat this piece. Okay, the next thing we need to do is we need to set a max date property of this datetime picker. So we can based on today's date and the term of the loan, so that the user cannot enter an invalid date that's way beyond the end of the loan. Okay, so this was done by some Googling around to figure out how to do that. So anyway, the DTP early payoff dot max date property is set to be date add. We'll start with the date interval of year, okay, and then we'll start with the credit dot term, which is, so let's assume 30 and today, right? So we're going to define the max date as 30 years from today, essentially. Okay, so to see how that sort of works, okay, we're not done yet here. We'll just run it. Okay, we'll assume the 30 here, right? Today's date as of this recording is March 21st. For you, it'll probably be something else, obviously, when you do this towards, I suppose, the end of April. And then you will see, especially if you collapse the dates or roll up the dates into years and then into decades, that this I don't think that can be done. It can be done even more than that. You can see that this goes about let's see, I guess should go here and scroll till you should stop. Maybe it was not. I have to change. I guess I have to change the value, perhaps. I'm not sure. Yeah, 2047, right? So I have to change the value to sort of, and this should have probably been done in like a load event in hindsight, but at any rate, you get the idea, which is that the datetime picker sort of maxed out 30 years from 2017, right, which is 2047. So I'm going to close that and then scroll down to the bottom, or towards the bottom of the loan class, where the two methods that are going to be used to calculate the remaining balance and interest rate saving based on that date value you pick from that datetime picker are going to be briefly discussed. I don't want to code these guys. I'm just going to uncomment them sort of, I guess, one by one here and just talk about it. Okay, so get remaining balance as of that particular early payoff date, right? Um, is used to calculate what is the remaining balance as of that date. Obviously, we'll start with entire principal, okay, which is the M amount, and then calculate number of periods between today and the early payoff date. So this is all based off today, and we use the months instead of years because that's how the periods on mortgage loans and auto loans and really any loans work. If it's a different time period, then you have to obviously modify this, right? So starting with the entire principal, we then loop right through right here. We loop right here. We loop through the we loop through all these periods, starting with the first one and going all the way to the that early period payoff date, right? Along the way, we subtract, as you can kind of see here, we subtract each month's contribution to the principal reduction, using this PPMT function you might recall from before, the principal portion of the payment. At the end, we will have the remaining principal owned. So it's sort of opposite of accumulated is subtracting, right? If the number of periods is 0, okay, in other words, the early payoff date is within the first month from today, which is sort of assumed not to be the case, then we'll assume we own the entire balance, which is obviously the case, right? And the loop will not execute at all, and the return value will be the entire principal, right? We could have done that. We could have avoided this, and this would still work here, but this makes it a little more clear. Hopefully, again, so there's some math to calculate the remaining principal. We've done that in IDSC 3101 in Excel. And the next function then is used to calculate the savings, if the loan, interest rate savings, if the loan is paid off early, right? So the first thing we do is to calculate the total interest, okay, as if the loan is not going to be paid off early at all, right? So this particular for next loop calculates the total essentially cost of the loan, if you want to think of it that way, from the first month to the last one. So if the term is 30, this is 360, right? Then what we do, we're going to do this accumulation of the interest, right, in a similar fashion as we've done for the principal, okay, going from today essentially to that period when the early payoff would take place, right? So that would be the accumulated interest that we then paid on a monthly basis, using this IPMT function, right? And then the difference between that and the total cost of the loan would be the savings. Okay, so again, we don't necessarily want to go into the nitty-gritty of finance here. The main point is that we have two slightly more complicated methods, right, when compared to the calculated monthly payment one, right, that can be applied to our credit object, in addition to just simply using this calculated monthly payment one. So we'll scroll back to the top, and what we'll do in the txt remaining principal.text box, we will display the calculation using the credit object, get remaining balance right here, and then provide the DT P early payoff dot value, which is the date currently selected, and then the whole thing is converted to string as currency. The same thing is going to be done here with interest saved by using the credit object and get what is it called? It's called calc. Where is it? I think it's at the top. Yeah, calc interest save with ETP early payoff dates, and again, because both are dollar amounts, they're going to be converted to currency, and I believe we might want to just have, because they're a relatively large number, ignoring the pennies, that totally doesn't doesn't matter. So to test this, we'll run the code. Okay, we'll trigger this event by going relatively far into the future, but not too far, right? Maybe 2025, and then let's say some April date, 15th. Okay, and you'll see the remaining principal and interest saving in 160,000 or in 80,000 range, and that should be sort of similar for you, although you will not get the same values because your current date or today's date will not be the same as mine. Okay, so we're going to close this. We're going to save the changes, switch back to the presentation, and pause.